Hi, everyone. Wait, is it good now? Yeah, okay. So hi, everyone. Thank you for Flower Airline to let me present my research about clustering federated learning for quality control in bioprocesses. So my research is within the advanced therapy medicinal product. So it's advanced therapy where we can provide personalized treatment. It can involve, for example, cell therapy. And the idea here is that we take the cell of the patient that can suffer from leukemia, and then we are processing those cells for a treatment ex vivo, and then we are going to re-administer the treatment afterwards in the patient. It's actually quite an effective therapy, but the issue is it's a very long and complex process, and it doesn't scale well. So what we try to do is we try to cut down the cost, and the way we try to do it is by trying to predict whether the batch is going to be conform or not for the patient. So for that we have in the bioreactor several measurements. It can be temperature, pressure, concentration of some components. But here the idea is that if we are able to detect as early as possible some faulty batches, then we can reduce the overall cost of the process, scaling further this medicine, and of course providing accelerated treatment. So the problem can be summarized in the following. So we have a regression involving critical process parameters, where we are aiming to predict control quality attributes such as cellular count or lactate concentration. Now, what we are focusing here on is the predictive model. And of course, what we have in the biopharma at AMP is that we have a lack of data because of the high expertise needed to annotate those data. Sometimes we don't have harmonization between all the site and manufacturer site production. You have complex patterns between the measurement, the site parameters, and also target variables, but also competitiveness among companies. And even sometimes within a company, several manufacturers or several sites are going to be in competition with each other. And of course, we have privacy-preserving regulations concerning the patients. So here, federated learning seems a really nice approach. And to test it, we try to work not directly on the ATMP because we don't have enough data. We are right now building this, but we are working on a proxy problem, which is the Chinese hamster ovary. It's a cell line widely used in biotech to produce therapeutical protein. And right now, the data that we have are from 6 sites with site-specific variability. So here, the colors illustrate a little bit the variation between all the sites. We have per site 20 training batches, 100 test batches, 7 measurement variables, and 7 control variables. And the model we are going to use is linear regression. It's an industry standard for its interpretability and ease to use, but also because you can forget to use deep neural networks in those small settings. So when we apply a naive, let's say classic federated learning, what we observe is that sometimes we could have performance where the federated model performs worse than the local model. It's particularly here present in the site C and D, where the relative root mean square error is better when we use the local model. So this complicates model selection at deployment, but also discourage collaborative learning, which is already hard to implement when we are talking with hospitals or manufacturers. So here we do not think that isolation is the best. We do not think that the let's say a universal approach, a universal federated model is the best. We think that client selective approach, clustering client with their compatibility, with their, let's say, similarity, can provide a very interesting scheme. And for that, we provide this baseline. So it's a pairwise federated learning. So we try to connect 2 silos that are the best match. And it's a very naive, let's say, collaboration scheme. But what we can observe is that it already produces interesting results. To read this graph is the following. So you have the first let's say, strategy is FL 3-on-6 clients. Here, at each round, 3 clients are participating. You have the FL 6-on-6 clients, so every client is participating. We provide 2 baselines. So the first one is the isolated, when everyone is not collaborating, and of course the centralized data, so everyone is putting all the data together to train one unique model. And what we observe is that right now, even with this early, simple scheme, we can have the same performance as the federated learning 6-on-6. However, the standard deviation is lower, and this is interesting. It means that we are reducing a little bit the dispersion of the performance. So basically, you have a more homogeneous results and a little bit more qualitative. Now, the take-home message of this presentation is that managing multi-site models requiring balancing specificity and universality, and this can be achieved through a clustered approach. Of course, it is right now an ongoing research, and the intention of this presentation is first to collect some feedback, but also to see if there are some people interested in collaboration. But of course, there are some mechanisms that can be provided, more advanced, that are going to ensure for every client taking part in the federated learning process a constructive peer learning. This concludes my presentation, so thank you for your listening.
Thank you so much, Dani. Do we have any questions in the room? I believe over here.